Hi, I'm Ezekiel Pigtaim from Group 8 and we are going to discuss all about file management. By the end of this chapter, we are expected to learn how files are organized locally, learn how they are stored physically, how they are accessed, and who is allowed to access them. File Manager. A file manager is a software program that helps a user manage all files on their computer. It is the software responsible for creating, deleting, modifying, and controlling access to files, as well as for managing the resources used by the files. For the efficiency of the file manager, there are a number of variables that directly affect the efficiency of the file manager, and these are how the system's files are organized, whether sequential, direct, or index sequential, how they are stored, how each file's records are structured, and how users access to all files that is protected. Next is how the file manager works. At first, the file manager keeps track of its files with directories that contain the file name, its physical location in secondary storage, and important information about it. Then, the file manager's policy determines where each file is stored and how the system and its users will be able to access them simply via commands that are independent from device details. Next is the computer system allocates a file by activating the appropriate secondary storage device and loading the file into memory while updating its records of who is using what file. Lastly, the file manager deallocates a file by updating the file tables and rewriting the file to the secondary storage device. Any processes waiting to access the file are then notified of its availability. The file manager can be compared to a librarian in the library because they perform similar tasks. Both librarian and file manager keeps track of items where they are stored. They both rely on policy on how a file should be stored, allocate each file when a user has been cleared for access, and then returns back the file into its proper location. When returned, then makes proper notation in the records. File management in the cloud. Cloud file storage is a method of storing data in the cloud that provides servers and applications access to the data through shared file systems. Before the cloud existed, the file manager had to maintain many files housed on the computer, including those that contain programs, data, and system instructions. Now, with cloud storage, many of these can now be stored on devices located in another part of the world and remain accessible via the internet. For the definitions, we have field, record, file, and database. Field is a group of related bytes that can be identified by the user with a name, type, and size. While record is a group of related fields, file is a group of related records that contains information to be used by specific application programs to generate reports. Lastly, the database is a group of related files that are connected at various levels to offer flexible access to the data stored in it. Interacting with the file manager. The file manager responds to specific proprietary commands to perform necessary actions. Some of the most common commands are open, delete, rename, and copy. For the examples of the interactive commands, we have open and close, which pertain to availability of file for program invoking it. The read and write, which are input and output commands. Modify, specialized write command for existing data files that allows for appending or rewriting records. Create and delete, which deals with system's knowledge of file. Rename, which allows user to change the name of existing file. Copy, which allows users to make duplicate copies of existing files and save if the file is used for the first time. If file and we use the save command, a file will be created. In creating a new file, we have the device dependency. If the file manager is required to provide detailed instructions for each system device, then it is a device dependent. And if the information is already available in a device driver, then it is said to be device independent. Next is typical volume configuration. Each secondary storage unit, whether removable or non-removable, is considered as a volume. A volume can be considered as multi-file volume or multi-volume files. Multi-file volume contains many files while the multi-volume files contains extremely large files spread across several volumes. Below is the volume descriptor, which contains the creation date, which shows the date when the volume was created, the pointer to directory area, which indicates first sector where the directory is stored, the pointer to file area, which indicates first sector where file is stored, the file system code, which is used to detect volumes with incorrect formats, and the volume name, which is the given name by the user to the volume. Master file directory, or MFD, is stored immediately after the volume descriptor and lists the names and characteristics of every file contained in that volume. File names can be program files, data files, or system files. Early operating systems supported only a single directory per volume. It contains names of files, usually organized in alphabetical, spatial, or chronological order. It is also simple to implement and maintain. The disadvantages of using a single directory per volume are it has long search time for individual files, especially when the files are arranged in an arbitrary order. If user has many files, small files stored in volume, the directory space fills before disk storage fills. Another is users cannot create subdirectories and they cannot safeguard their files. Lastly, each program needs a unique name. Introducing subdirectories. A subdirectory is created when a user opens an account to access the computer system. Subdirectories are treated as a file. Some operating systems call these subdirectories folders or directories. File managers now encourage users to create their own subdirectories. Subdirectories are implemented as an upside-down tree. In the upside-down tree, we have the root, which is the MFD shown at the top of the upside-down tree. The node is the directory files. Branch is the directory entry point, and the leaves are all program and data files subsequently added to the tree. Leaves are often represented by the circles here. Next is the file naming conventions. File name has two components, which are the relative file name and extension. The absolute file name or complete file name is a long name that includes all path information, while a relative file name is the name that differentiates it from other files in the same directory. Relative file name is also a name without path information and can vary in length from one to many characters and can include letters of alphabet and digits. For the extensions, extensions are appended to relative file name. It is composed of 2 to 3 characters separated by period and identifies file type or contents. The examples are the notepad.txt, and image.png. The extensions here are the .txt and the .png. Every operating system has specific rules that affect length of relative name and types of characters allowed. For the Windows, it contains drive label and directory name, relative name, and extension. For network with Open VMS Alpha, it has node, volume or storage device, directory, subdirectory, relative name and extension, and the file version number. For Unix or Linux, it has forward slash first subdirectory, and the file's relative name.
I'm Jacob Wanzing from Group 8, and we're going to talk about access methods and file management. So for the sequential access, when a file has been organized in a sequential fashion, it can support sequential access to its records, and these records can be of either fixed or variable length. The file manager uses the address of the last byte rate to access the next sequential record. Therefore, the current byte address, or the CBA, must be updated every time a record is accessed, such as when the read command is executed. We can see here the blocks represent the fixed length, and this set of blocks, example B, represents the variable length with the record lengths with different record length values. For the sequential access of fixed length records, the CBA is updated by incrementing it by the record length RL, which is a constant. So the formula is CBA is equals to CBA plus RL. For the sequential access of variable length records, it is quite the same. The formula, just we're gonna add an N, which holds the value shown in the figure here, or M. It really depends. Now we're gonna talk about direct access. If a file is organized in a direct fashion, and if the records are at fixed length, it can be accessed in either direct or sequential order. In the case of direct access with fixed length records, CBA can be computed directly from the record length and the desired record number. The information of record number is provided through the read command -1. So it is CBA is equals to quantity of Rn minus 1 multiplied by record length. Direct access with variable length records is not quite possible because computing the address for variable length is very hard. Now we're going to talk about levels in the file management system. Here is the hierarchy standard file management system from the file manager down to the device manager. The highest level module is called the basic file system. It passes information through the access control verification module to the logical file system, which in turn notifies the physical file system, which works with the device manager. Each level of the file management system is implemented using the structured and modular programming techniques that also set up a hierarchy. That is, the higher positioned modules pass information to the lower modules so that they in turn can perform the required service and continue the communication down to the chain to the lowest module. So the highest module is the file manager and the lowest module is the device manager. The device manager communicates with different hardwares like the mouse and the keyboard, and it is how it works. The lowest module communicates with the physical device and interacts with the device manager. Only then the record is made available to the user's program. That is all. Thank you.
Access Control Verification Module. In this segment, we will discuss all about access control of a file. But first, what is access control? Well, access control is a critical element of system security. Basically, it identifies who is allowed to access which files. as well as what operations each user is allowed to perform. Back then, operating systems could not support file sharing among users. For example, if it had 10 users, then it needed 10 copies of a compiler. Now, systems require only a single copy to serve everyone, regardless of the number of active programs in the system. In fact, any file can be shared from data files and user-owned program files to system files, if the licensing agreement allows. The advantages of file sharing are numerous. In addition to saving space, it allows for synchronization of data updates, as when two applications are updating the same data file. It also improves the efficiency of the system's resources, because if files are shared in main memory, then there's a reduction of I/O operations. However, as often happens, progress brings problems. The disadvantage of file sharing is that the integrity of each file must be safeguarded, and this calls for control over who is allowed to access the file and what type of access is permitted. Now, there are 5 possible access levels that can be granted to a user for a file: the ability to read only, write only, execute only, delete only, or some combination of these 4. Now, we discuss about the access control matrix. The access control matrix uses a column to identify a user and a row to identify a file. Such an organization is intuitively appealing and easy to implement. But because it can grow to a huge size, it works well only for systems with few files and/or few users. The intersection of the row and column contains the access rights for that user to that file, as shown in the table above. Notice that user 1 is allowed unlimited access to file 1, whom is allowed only to read and execute to file 4, and is denied access to the other 3 files, as shown. In the actual implementation, the letters RWED are represented not by letters but by the bits 1 and 0. A 1, which indicates that access is allowed, and a 0, which indicates that access is denied. Therefore, as shown in this table, the code for user 2 for file 1 would read 1010 and not R-E-. As we can see, the access control matrix is a simple method, but as the number of files and users increase, the matrix becomes extremely large, sometimes too large to store in main memory. Another disadvantage is that a lot of space is wasted because many of the entries are null, such as shown from the table before, from the previous slide, where user 3 is not allowed into most of the files, and file 5 is restricted to all but one user. A scheme that conserves space would have only one entry for user 3, or one for file 5, but this is incompatible with the matrix format. Now, the access control list is a modification of the access control matrix. Here, each file is entered in the list and contains the names of the users who are allowed to access it and the type of access each is permitted. To shorten the list, only those who may use the file are named. Those denied any access are grouped under a global heading, such as World, as shown in the next table. This is a table which is an access control list showing which users are allowed to access each of the 5 files. This method uses storage space more efficiently than an access control matrix. Some systems shorten the access control list even more by establishing categories of users, such as use system, owner, group, and role, as shown in the table. The system, sometimes called admin, group is designated for system personnel who have unlimited access to all files in the system. The owner, sometimes called user, controls all files in the owner's account. An owner assigns the group designation to a file so that all users belonging to the owner's group have access to it. World is composed of all other users in the system. That is, those who don't fall into any other of the three categories. In this system, the file manager designates default types of access to all files at creation time, and it's the owner's responsibility to change them as needed. Next. And lastly, the compatibility lists. A compatibility list shows the access control information from a different perspective. Here it lists every user and the files to which each has access, as shown in this table above. When users are added or deleted from the system, capability lists are easier to maintain than access control lists. Well, in other words, a capability list shows files for each user and requires less storage space than an access control matrix. Of the three schemes described so far, the one most commonly used is the access control lists. However, capability lists are gaining popularity because Unix-like operating systems, including Linux and Android, control devices by treating them as files. Although both methods seem to be the same, there are some subtle differences which is best explained with an analogy. A capability list may be equated to a specific concert tickets that are only made available to individuals whose name appear on the list. On the other hand, an access control list can be equated to a reservation list for a restaurant that has limited seating, with each seat assigned to a certain individual. One of the greatest examples of an access control list would be the list-l command from any Unix-based systems. It shows any permissions that a file has to show: its owner, its group owner, its size, and its date created.
Data compression. Why data compression? Because it makes optimal use of limited storage space, also save time and help to optimize resources. The data compression is about storing and sending a small number of bits. There's two major categories for methods to compress data. First is the lossless and the second is the lossy methods. So the next one is the text compression. Most text compression methods are either statistical or dictionary based. When it says that the latter class breaks the text into fragments that are saved in a data structure called the dictionary. When a fragment of new text is found to be identical to one of the dictionary entries, a pointer to that entry is written on the compressed string to become the compression of the new fragment. First example of the text compression or method is the run length encoding. It is one of the basic techniques that work in lossless method. Example, using RLE compression for compression this text, a scan line contains a run of numbers to all is too well. So the solution is, in this example, the compression way with text to all is too well will not work. Clearly, the decompressor should have a way to tell that the first two is part of the text while the others are repetition. So the one way to solve this problem is to precede each repetition with a special escape character at. So the answer is 2 at 2L, IST at 2O, V at 2L. Because the string is longer than the original string because it replaces two consecutive letters with three characters. We have to adopt the convention that only three or more repetitions of the same character will be replaced with a repetition factor. The next one is the Huffman coding. It is the popular method for data compression. Entropy encoding algorithm used for lossless data compression. It is also a method of storing strings of data as binary code in efficient manner. It is also a successful compression method used originally for text compression. It assumes that each character is stored as an 8-bit ASCII code. So we have an example here. They say that use a simple alphabet with the following frequencies of occurrence. Let we have the text message here. So the solution is first construct the frequency table, the character, and the probability. We can see there's a to G in the character and the corresponding value for the probability. Next thing is sort the table in descending order. The character starts from letter F to B. And also there is a value for the probability. Next one is let's derive the Huffman tree. As you can see, there's a graph here to show how to get the Huffman tree. And the next one is the generating Huffman code. The last step or technique in the text compression is Shannon-Fano coding. It is first well-known coding method. Use the probability of each symbol's occurrence to construct a code in which each code word can be different length. So let's have an example. Use a simple alphabet with the following frequency of occurrence. Let we have the text message as you can see in the figure. So the solution is first the constructing of the frequency table. It's like the Huffman's method. We have the character and also the probability, and each character have the values, corresponding values from A to G. So next step is sort the table in descending order from F to B. The next is the table division. Let's divide the table into two halves so the sum of the frequencies of each half are as close as possible. And also assign 1 bit of the sample. So next thing is the image and sound compression. Lossy compressions allows a loss of data from the original image file to allow significant compressions. This means that the compression process is irreversible, as the original file cannot be reconstructed. The specifics of the compression's algorithm are highly dependent on the type of file being compressed. We all know the JPEG, right? It is a popular option for still images and MPEG for video images. For video and music files, the International Organization for Standardization, ISO, has issued MPEG standards that are international standards dealing with the compressions, decompression, processing, and coded representation of moving pictures, audio, and their combinations. So for our conclusion, the file manager controls every file in the system and process user commands read, write, modify, create, delete, and so on to interact with available files on the system. It also manages the access control procedure to maintain the integrity and security of files under its control. Second is to achieve its goal, the file manager must be able to accommodate a variety of file organization, physical storage allocation schemes, record types, and access methods. And as we've seen, this often requires complex file management software. Third is, in this chapter we discuss sequential, direct, and index sequential file organization. contiguous, non-contiguous, and index file storage allocation, fixed length versus variable length records, tree method of access control, and also my part is the data compression techniques. Lastly is to get the most from a file manager, it's important to realize that the strengths and weaknesses of its segment, which access methods are allowed on which device and which record structures, and the advantage and disadvantage of each. Thank you.
A database consists of a huge amount of data. The data is grouped within a table in RDBMS, and each table have related records. A user can see that the data is stored in form of tables, but in actual this huge amount of data is stored in physical memory form of files. File organization. What is file organization? File organization refers to the logical relationships among various records that constitute the file, particularly with respect to the means of identification and access to any specific record. In simple terms, storing the file in certain order is called the file organization. These are the types of file organization. There are 5 types: sequential file organization, heap file organization, hash file organization, B+3 file organization, clustered file organization. First off is a sequential file organization. This is the easiest method for file organization. In this method, the files are stored one after another in a sequential manner. There are 2 ways to implement this method. One is the pile file method, and second is the sorted file method. Pile file method. This method is quite simple, in which we store the records in a sequence one after another in the order in which they are inserted into the tables. Sorted file method. In this case, as the name itself suggests, whenever a new record has to be inserted, it is always inserted in a sorted, ascending or descending manner. Sorting of records may be based on any primary key or any other key. Next is the heap file organization. Heap file organization works with data blocks. In this method, records are inserted at the end of the file into the data blocks. No sorting or ordering is required in this method. If a data block is full, the new record is stored in some other block. Here, the other data block need not to be very next data block, but it can be any block in the memory. It is responsibility of DBMS to store and manage the new records. Pros and cons of heap file organization. For pros, fetching and retrieving records is faster than sequential record, but only in case of small databases. When there is huge number of data needs to be loaded into the database at time, then this method of file organization is best suited. The cons, problems of unused memory blocks and inefficient for larger databases. Hash file organization. There are 3 parts of hash file organization. Those are data bucket, hash function, and hash index. And there are 2 ways of hash file organization. First is static. In static hashing, when a search key value is provided, the hash function always computes the same address. For example, if we want to generate address for student ID 76 using mod5 hash function, it always results in the same bucket address, 4. There will not be any changes to the bucket address here. Hence, number of data buckets in the memory for the static hashing remains constant throughout. The next type is dynamic hashing. The drawback of static hashing is that it does not expand or shrink dynamically as the size of the database grows or shrinks. In dynamic hashing, data buckets grows or shrinks, added or removed dynamically as the records increases or decreases. Dynamic hashing is also known as extended hashing. The hash function is made to produce a large number of values. For example, there are 3 data records D1, D2, and D3. The hash function generates 3 addresses: 1001, 0101 and 100, respectively. This method of storing considers only part of this address, especially only first one bit to store the data. So it tries to load 3 of them at address 0 and 1. Next is the B plus 3 file organization. B plus 3, as the name suggests, it uses a tree-like structure to store records in file. It uses the concept key indexing, where the primary key is used to sort the records. For each primary key, an index value is generated and mapped with the record. An index of a record is the address of record in the file. B plus tree is very much similar to binary search tree, with, with the only difference that instead of just two children, it can have more than two. All the information is stored in leaf node, and the intermediate nodes access pointer to the leaf nodes. The information in leaf nodes always remain a sorted sequential linked list. Pros and cons of B plus tree organization. First, the pro: tree traversal is easier and faster. Searching becomes easy as all records are stored only in leaf nodes and are sorted sequential linked lists. There is no restriction on B plus tree size. It may grow or shrink as the size of data increases or decreases. Cons: it is inefficient for static tables. Last is the cluster file organization. In cluster file organization, two or more related tables are stored within same file known as clusters. These files will have two or more tables in the same data block, and the key attributes which are used to map this table together are stored only once. Thus, it lowers the cost of searching and retrieving various records in different files as they are now combined and kept in a single cluster.